Hello, we are Group 4 and this is our project Sentimental Analysis on IMDb Movie Reviews. So in this project we have built completely end-to-end system that can read any movie reviews and can instantly classify it as whether the feedback is positive or negative. We trained a neural network model using IMDb dataset and evaluated it using ROC curve and confusion matrix. And finally we connected everything into a working web interface and using a Flask as backend and HTML as frontend. So now I'll show how it will show whether the feedback is positive or negative. So here I'm giving negative feedback and let's analyze here, and it's giving the feedback as negative.
Now let's begin with the workflow of our project. We begin by running two components, that is backend and then front end. First we get into the project directory using the command cd sentiment underscore project. Then we have to activate the virtual environment. So we can see that here the virtual environment is activated. Then we have to get into the backend directory and run the backend server. You can see that the backend is serving in the Flask app and it is running on the local host. The next step is to start the front end. So we have to open the new command window and then give the commands to run the front end. So this is our front-end interface. Here we can type any movie review. The model will classify whether it is positive or negative. So let's try it out by giving some of the examples. Now first I will give some positive review. So when I click on analyze, it shows that the sentiment is positive and the confidence is 0.83. In the same way we can give the negative comments and it will show whether it's negative and what is the confidence. So let us try out some. So this is a negative review. When I click on analyze, it shows that the sentiment is negative and the confidence is 0.17. Now I'll tell the basics about how the review I gave is classified whether it is positive or negative. First, the review we give will be tokenized and it is changed into the number. Then the reviews are made of the same length by adding 0 if needed. These reviews are sent into the embedding layer so that it learns the meaning of the each word. The dense neural network look at these words meaning and decides whether it is positive or negative. If the total score is less than 0.5, then it is classified as negative. If it is greater than 0.5, then it is classified as positive.
So I'm going to explain about ROC, AUC and confusion matrix and how I have implemented these three. So the ROC curve means receiver operating characteristics. It's a graph that separates positive and negative reviews. So the lower x-axis is the false positive rate and the y-axis is considered as true positive rate. The good model is evaluated as per if the curve is to the top left corner. Explain about AUC. AUC means area under curve. It's a single number between 0 and 1. It tells how good the model is. If the AUC rate is above 0.8, then the model is considered to be good, and if the AUC rate is below 0.5 or 0.5, the model is considered useless. Confusion matrix is a 2 into 2 matrix that tells how my model's prediction match the actual value. There are 4 values, so true positive, true negative, false positive and false negative. So true positive is nothing but if the predicted value is positive and the actual value is positive, then it is a true positive. Then if the predicted value is negative and the actual value is negative, then it's a true negative. But if the predicted value is positive and actual value is negative, then it is called false positive. predicted value is negative and the actual value is positive, then it is false negative. After training dense neural network, I will evaluate my model using ROC, AUC and confusion matrix. ROC curve shows detecting positive reviews and wrong prediction. My AUC score is 0.94, which is a quite good score for reviewing positive and negative reviews. The confusion matrix tells how exactly my predictions are correct and where my model is getting confused. It gives the detailed explanation about my model's accuracy and mistakes.
Now I will explain the code for training our model. Here firstly we will import the important libraries, padding and also evaluation metrics, and then we load the top 10,000 words from the data set, and then pad the reviews from that data set to 200 words, which will make the reviews of same length. Then we create the LSTM model. LSTM layer learns the meaning and sequence of the words. Dropout prevents overfitting. And finally, the dense layer with the sigmoid output gives us a value between 0 and 1 to classify reviews as positive or negative. We then finally we'll compile the model using binary cross entropy and random optimizer, and then train it for 3 epochs with the validation split of 20%. After training, we evaluate it using the ROC curve and confusion matrix.
So now I'll explain about the confusion matrix code. Here, import matplotlib.pyplot is used for creating the graphs, and import numpy is used for numbers and arrays. From sklearn.metrics is used for evaluating the machine learning modules. And here, pl.figure is used to set the size of the graph in 6 into 5 inches. And plt.im.show means it will show the confusion matrix in the form of images. And then here there are two classes, negative and positive classes. Here plt.xtickets and plt.ytickets will give the names instead of the numbers. And here this formula thresh is equal to cm.max divided by 2, which will give the half of the highest number in the will loops through the each cell of the confusion matrix. And here if the cell value is greater than if the cell value is greater, it will print the text in black. If the cell value is smaller, it will print the text in white. And at the end, plt.show is used to give the image of the confusion matrix. Here now I'll explain about the ROC curve code. So here, import ROC curve will calculate the points of the ROC curve. AUC means area under the curve. And here FPR means false positive rate. TPR means true positive rate. AUC tells how good the model is. If the value is 1, then it is a perfect model. If the value is 0.5, then it is useless model. The higher the AUC value, higher the performance. So next here, it will plot the true positive rate versus false positive rate. And it will add the label by giving the values up to 4 decimal values. So here plt.show will show the ROC curve in the form of image.